Welcome to the world of online learning. I am Dr. G.K. Viju, Professor, University of Garden City, Khartoum, Sudan. We at GK Online Learning Tutorial emphasize on the topics from software engineering, project management, quality management, strategic management, and mathematics. Today we are going to discuss the topics from software engineering. Please subscribe to our channel for continuous support. So let us start. Chapter number 2, Software Development Lifecycle. Lifecycle model. A software lifecycle model, also called as process model, is a descriptive and diagrammatic representation of the software lifecycle. A lifecycle model represents all the activities required to make a software product transit through its lifecycle phases. In system engineering, information system, and software engineering, the system development lifecycle, also referred to as the application development lifecycle, which is a process of planning, creating, testing, and deploying an information system. The system development lifecycle concepts apply to the range of hardware and software configuration, as a system can be composed of hardware only, a software only, or a combination of both. There are usually 6 stages in the cycle: requirement analysis, design, development and testing, implementation, documentation, and evaluation. A system's development lifecycle is composed of a number of clearly defined and distinct work phases which are used by systems engineers and system developers to plan for, design, build, test, and deliver information systems. Like anything that is manufactured on an assembly line, an SDLC aims to produce high quality systems that meets or exceed customer expectations based on customer requirements by delivering systems which move through each clearly defined phase within scheduled timeframes and cost estimates. Computer systems are complex and often link multiple traditional systems potentially supplied by different software vendors. To manage this level of complexity, a number of SDLC models or methodologies have been created, such as waterfall, spiral, agile, software development, rapid prototyping, incremental, and synchronize and stabilize. In project management, a project can be defined both with the project lifecycle and an SDLC, during which slightly different activities occurs. According to Taylor, the project lifecycle encompasses all the activities of the project, while the system development lifecycle focuses on realizing the product requirements. System development lifecycle is used during the development of an IT project. It describes different stages involved in the project from the drawing board through the completion of the project. The SDLC is not a methodology per software engineering, but rather a description of the phase in the life cycle of a software application. These phases are investigation, analysis, design, build, test, implement, and maintenance, as well as support. All software development methodologies, such as the more commonly known waterfall and scrum methodologies, follow the SDLC phases, but the method of doing that varies vastly between methodologies. Different lifecycle models. Many lifecycle models have been proposed so far. Each of them had some advantage as well as some disadvantage. A few more important and commonly used lifecycle models are as follows: classical waterfall model, iterative waterfall model, prototyping model, evolutionary model, and spiral model. How this SDLC works? SDLC works by lowering the cost of software development while simultaneously improving the quality and shortening the production time. SDLC achieves these apparently divergent goals by following a plan that removes the typical pitfalls of software development projects. That plan starts by evaluating existing systems for deficiencies. Next, it defines the requirements of the new system. It then creates the software through the stages of analysis, planning, design, development, testing, and deployment. By anticipating costly mistakes by following to ask the end users of clients for feedback, SDLC can eliminate redundant rework and after the fact fixes. It also important to know that there is a strong focus on the testing phase. As the SDLC is a repetitive methodology, you have to ensure code quality at every cycle. Many organizations tend to spend few efforts on testing while a stronger focus on testing can save them a lot of rework, time as well as money. Be smart and write the right types of tests. There are some primary reasons why SDLC is important for developing a software system. It offers basis for project planning, scheduling and estimating, provides a framework for a standard set of activities and deliverables. It is a mechanism for project tracking and controlling, increase the visibility of project planning to all involved stakeholders of the development process, increased and enhanced development speed, improves client relations, helps you to decrease project risk and project management plan overhead. So first one, classic waterfall model. The classic waterfall model is intuitively the most obvious way to develop software. Though the classic waterfall model is elegant and intuitively obvious, it is not a practical model in the sense that it cannot be used in actual software development projects. Thus, this model can be considered to be a theoretical way of developing software. Or in other sense, classical waterfall model is the basis software development lifecycle model. It is very simple but idealistic. Earlier this model was very popular, but nowadays it is not used. But it is very important because all the software development lifecycle models are based on the classical waterfall model. Classical waterfall model divides the lifecycle into a set of phases. This model considered that one phase can be started after completion of the previous phase. That is, the output of one phase will be the input for the next phase. Thus, the development process can be considered as a sequential flow in the waterfall. Here, the phases do not overlap with each other. So here you can see the diagram for a classical waterfall model starting with the feasibility, requirement analysis, design, coding, testing and maintenance. What is feasibility? It is the main goal of this phase. Or the main goal of this phase, the feasibility study phase, is to determine whether it could be financially and technically feasible to develop the software. The feasibility study involves understanding the problem and determine the various possible strategies to solve the problem. These different identified solutions are analyzed based on their benefits and drawbacks. The best solution is chosen and all the other phases are carried out as per this solution strategy. Requirement analysis and specification. The aim of the requirement analysis and specification phase is to understand the exact requirement of the customer and document them properly. This phase generally consists of two different activities, that is requirement gathering and analysis, and second one, requirement specification. What is requirement gathering and analysis? Firstly, all the requirements regarding the software are gathered from the customer and then the gathered requirements are analyzed. The goal of the analysis part is to remove incompleteness and inconsistencies. Incompleteness, that means incomplete requirement is one which some part of the actual requirement have been omitted. Inconsistencies, that is, inconsistent requirement is one which some part of the requirement contradict with some other parts. And requirement specification, these analyzed requirements are documented in a software requirement specification or SRS document. SRS documents serve as a contract between the development team and the customers. Any future dispute between the customers and the developers can be settled by examining the SRS document. Design. The aim of the design phase is to transform the requirement specified in the SRS document into a structure that is suitable for implementing in some programming languages, coding and testing. In coding phase, software design is translated into source code using any suitable programming language. Thus, each designed module is coded. The aim of the unit testing, that is the first phase in testing, is to check whether each module is working properly or not. Then comes integration and system testing. Integration of different modules are undertaken soon after they have been coded and unit tested. Integration of various modules is carried out incrementally over a number of steps. During each integration steps, previously planned modules are added to the particularly integrated systems and the resultant system is tested. Finally, after all the modules have been successfully integrated and tested, the fully working system is obtained and system testing is carried out on this. System testing consists three different kinds of testing activities as alpha testing, the system testing performed by the development team, beta testing, the system testing performed by a friendly set of customers, and acceptance testing. After the software has been delivered, the customers perform the acceptance testing to determine whether to accept that delivered software or to reject it. Maintenance. Maintenance is the most important phase of the software lifecycle. The effort spent on maintenance is the 60% of the total effort spent to develop a full software. There are basically three types of maintenance. Corrective maintenance, that is, this type of maintenance is carried out to correct errors that were not discovered during the product development phase. Perfective maintenance, this type of maintenance is carried out to enhance the functionalities of the system based on the customer's request. Adaptive maintenance is usually required for porting the software to work in a new environment, such as work on a new computer platform or with a new operating system. This is about classical waterfall model. Shortcoming of the classical waterfall model. The classical waterfall model is an idealistic one since it assumes that no development errors is ever committed by the engineers during any one of the life cycle phase. However, in practical development environment, the engineers do commit a large number of errors in almost every phases of the life cycle. The source of the defects can be many: oversight, wrong assumptions, use of inappropriate technology, communication gap among the software or the project engineers. This defect usually gets detected much later on the development life cycle. For example, a design defect might be gone unnoticed till they reach the coding or testing phase. Once a defect is detected, the engineers need to go back to the phase where the defect had occurred and redo some of the work done during that phase and the subsequent phase to correct the defect and its effect on the larger phases. Therefore, in any practical software development, it is not advisable to strictly follow the classical waterfall model. This is the end of the second part. If you are having any queries, please write to the mail ID provided below. Thank you.